All right, here is the last question, which is question 5 under section A. The question reads, in the figure below, O is the center of a circle where line AB is equal to line CD and angle COD is equal to 85 degrees. We're asked to find the angle AOB, BCD, BAD, BOD, and lastly OBD. Okay, let's get started with the solution. The first angle is angle AOB. Let us locate it. AOB. So we are referring to this angle right here, which is this one. And you should observe that this angle and this angle are opposite to each other. So therefore, they must be equal to each other. So as I walk, I level. So let me level this one as 85. So we can say that angle AOB is equal to 85 degrees. You can always state the reason because they are opposite angles. It is opposite to which angle? COD. Now let us move on to the second one. We want to find angle BCD. Let us define it here. BCD. Okay, we are looking for this angle right here. You should know that this triangle COD is an isosceles triangle, and an isosceles triangle has all its base angles equal. So these two angles must be equal to each other. And from circle theorem, if a chord, this is a chord CD, subtends an angle to the center, the plane figure formed is an isosceles triangle. So since it is an isosceles triangle, and you know that the sum of the interior angles equal to 180, so how can we find one of the angles? We can subtract this angle from 180 and divide the result by 2. So let's write it here. Angle BCD is equal to 180 degrees minus 85 degrees divided by 2 because the two angles are equal. And 180 minus 85 will give us 95 divided by 2. And if you divide that by 2, you're going to obtain 47.5 degrees. This is 47.5 degrees. So let me write it here for reference. This angle right here is 47.5 degrees. So the next one that we are looking for is BAD. So let's locate it. BAD. This is B, this is A, and this is D. Okay, we are looking for this angle right here. This is a chord. Remember, BD is a chord. If two or more angles are formed from the same chord to the circumference, they must be equal. Therefore, you can see this chord forms this angle. The same thing, it forms this angle. Therefore, the two angles must be the same, 47.5 each. So, number 3, we are looking for BAD. It is equal to the same thing, 47.5, but you can state the reason. BAD equal to BCD, all formed from the same chord. They are all formed from the same chord. Now let us take number 4. We are looking for BOD. Let's locate it. BOD. BOD. This is the angle we are looking for. There are so many ways we can find it, but since we have two other angles here, we can use angle at the center. You know, angle at the center is equal to 360, and this angle must be equal to this angle. So whatever angle you obtain for the 2, we divide by 2. So we can subtract this and this from 360 and divide the result by 2. So BOD will be equal to 360 degrees minus 2 of those angles because they are the same, 85, 85, 85 degrees. Then you divide the result by 2. This is equal to 180 degrees minus 85 degrees, because this 2 will go here 180 times and it can go here 1 time. And 180 minus 85 will give us 95. So that angle is 95 degrees. So the last one, we are looking for angle OBD. Remember, this is 95. OBD. All right. Remember, this is also an isosceles triangle. So we can subtract 95 from 180 and divide the result by 2 because B and D are all the same. OBD will be equal to 180 degrees minus 95, right? 95. And since the two angles are the same, we divide by 2. This is equal to 180 minus 95 will give us 85. We have divide by 2. And 85 divided by 2 will give us 42.5. So we have 42.5 degrees. So this is the angle OBD. And this is all about question number 5. Now we're going to move on to section B, which starts from question number 6.